Alright guys, so I removed the 138 right here and I put it in my IC tester, and I'm like, oh boy, that's not a good sign. 138. I'm like, oh, that's good, huh? So I was like, okay, pin 4 was tied high, so I started beeping it out, and it's tied to pin 20. And I'm like, wait a second, the schematic says it's connected to memory refresh, which pin 20 is the IRQ, one of the IRQ signals. I got to looking at the schematic a little bit better, and I pulled the wrong one. I've been looking at the wrong one. That's not even the right chip I'm supposed to be looking at, for crying out loud. So I'm going to put a new 138 in here. And you know what? I got the desoldering gun out. I might as well just, I'm just going to replace this. Because I did verify that the 74, the 04 was good, which fed the signal to this. Nope, you know what? I'm going to hook the flute back up, and we're going to verify that this thing is not working before we go pulling it. So let's do that. I'm beginning to think we might just have funky RAM, because I don't see where the decoding is not working. And look at what I got going on here. I'm doing a RAM check at 6000 to 63 FF. This will go between FF. Let me stop it. And now loop. Yeah, see, it's just garbage. So I think I am going to see, now it's it goes between good and not good. I don't know. These controlling signals are from the address bus. These guys. These are the enables. This one's high all the time. So that's good. See, right now it's telling me that the RAM is good. If the RAM are funky and they're, see, the data bus is shared between the RAM and this ROM. So what could be happening is, number one, the 138 still could be bad. And, or these are corrupting the data bus, or this is corrupting the data bus. This is a data bus problem. But I think what I'm going to do is I'm going to pull these two RAMs. I might just replace this 138 first. Yeah, let me think about what I'm going to do here. I doubt it's this. It'd be more susceptible to be these two guys. Or the 138. So we'll see. after replacing about everything in the decoding section of this thing, I removed the ROM, thinking maybe the ROM was corrupting the data. And oddly enough, after I replaced this 04 and this 138 over here, then I got a decoding error when trying to reach the RAM. It was giving me bit 4 decoding error, which was something new. Before it was just it was super flaky. It kind of worked, it didn't work, it whatever, you know. You saw that. So I got to looking at my work, and there was a broken trace right there. So I had to fix that trace. And now I am reading the RAM. I put a 28 pin socket in here, and I put a red dot marking pin 1 on both the 24 pin BIOS ROM that is in it. And you can also burn a 2764 for this and just change some jumpers around. So I wanted to, you know, put dots where it's justified for pin 1. But so I'll put that BIOS ROM back in it, and this thing should work now. So let me grab that BIOS ROM. I'm actually cleaning it right now in Tarnex because it's a Silver Leg chip. So I'm gonna clean it up, wash it, and dry it, and we'll put it in here, and hopefully we'll read that, and this thing will work. It's kind of rebuilt. New RAM, new logic, decoding logic, new clock logic here. So yeah, let me go ahead and get that ROM situated. Okay, so I got the BIOS ROM put back in. I'm running it on the Fluke, and as you can see, we are good to go. Repaired. And what I believe the main problem was, is this one was dead before I did anything to it, is it was something in the decoding, or the timing of the decoding or something was funky. And then I compounded things by breaking a trace. But now it's good to go. I'll do the ROM test do a ROM test here. This should be good. Alright, and our RAM is at 6063FF. This is the CPU's program RAM. And good to go, and run. And there she is. Good to go. And this one, with all this new decoding logic and new RAM and cleaned up, socketed everything, I think this is the one I'll keep, because it is no longer dead. Alright. 4 working Colecovision boards. Cleaned up. They'll all have new sockets. And I will continue this video series. Once I get those parts in the mail, we'll solder those things in. We'll test this baby, these four guys out. All right. See you then. Okay, I have discovered something. And you know what? I just now noticed. I want to put the original CPU back in this thing. This guy right here is the original Z80 that was in this. I had to repair a leg. One of the legs came off on the end there. But I want to put this back in. So let me do that really quick and I'll be right back and show you what I found. It's running, by the way. You can see. But there is a problem. And it was probably the whole problem all along. I don't think anything was bad logically, and I'll explain. Let me put this guy in though. Okay, I have the original Z80 back in it, and of course it is running. Now watch though. I will turn it off, turn it back on. Goofy. Now check this out. I will take my probe and let's look at the pin 1 of this 04. See how it's not good? I will hit reset and hold the probe on pin 1. I can do it, see, with the do it like this. And watch it settle down. See that? Once it settles down, then we get that. So I'm going to look at the clock circuit because that's where the problem's at. It's this clock circuit. And it starts with the crystal, and then there's going to be a couple capacitors that like bias the there's always like two 22 picofarad caps or whatever that are in circuit with a crystal to help set the frequency, I suppose, or whatever. I'm not gonna act like I know everything about, you know, the workings of a crystal, but I do know that there's always a couple capacitors with 22 picofarad, 33 picofarad, something like that. And yeah, so something's up with that. Watch, I'll turn it off and I'll turn it back on. It won't work. It's not working, just trust me. And watch, we'll look at pin 1. We'll be all fuzzy and stupid. See? Now give it a minute. It might settle down on its own. Yep, there it goes. Now I can hit reset and it'll work. See, it's still off. But if I reach over and hit reset, there it is. So it's either a bad crystal or the capacitors are bad or something. So I'm going to look into that. Okay, back to the schematic. I'm kind of just going over. Here is pin 1. Remember, you probe pin 1, it's all fuzzy, and then it straightens around, and that basically, I mean, that leads to the video clock. And I've interpreted this schematic. You see how CPU clock is inside? That's probably meaning it's coming in. And this is outside video clock, so that probably means that it's going out. So if that is the case, we got CPU clock coming in, and it's going to go through this transistor, And the emitter is high. The emitter is pulled high. So this is set up not as a traditional, common emitter situation. This has got to be a collector. If this goes on, it's just going to go to 5 volts. If the CPU clock is coming in, yeah, this is a common base setup or something like that. So it's just gonna, this clock is gonna come through here and clock these two things. I could check this transistor. I could replace this 3904. This thing, the output of this circuit clocks the 74 right here. And this CPU clock, this has got to be an output off of this. See, this is where the schematic doesn't make sense to me. This comes out. Unless this signal is both going that way and coming back this way to be the data pin of this. I mean, yeah, that's what it looks like. It looks like this signal goes out to the CPU clock and comes back through as the data pin for this and the clock for this. So I think I'm going to replace this guy because it's just easy. This 3904 is in that circuit. That's just an easy replacement. So I think that's where I'll start. Maybe this thing is delayed or something. I don't know. But let's go ahead, replace that guy, and see if this clears up. It might just be the crystal. Who knows? But I'm going to start right here with this guy. Okay guys, really quick. I went over and looked at the board, and this is not right. This transistor is a 3906. It's a PNP, which makes more sense. As I was looking at this, I was like, what? I don't get this. I mean, you have to have, for that to bias this has to be a higher potential than this. This is a PNP. It's actually a PNP transistor, so the arrow is the other way. You're going to have a higher potential here than you do here. So that's going to turn this on, and this is not in a common, common transistor, how they're commonly, you see them commonly, with a common emitter, the emitter grounded, or the emitter making its way to ground. So this is actually it'd be a common base. Basically, transistors can be set up three ways: common emitter, common collector, and common base. And each of them does something different. Like a common emitter is the most widely used because it amplifies both current and voltage. And like common collector is I believe a voltage amplifier only, and common base is a current amplifier. So I think what's going on here is when this is always going to be a higher potential than this, so this is always on. So whatever's over here, you're getting a higher current gain through the base. So your signal's coming through the base, I believe, is what's going on. That's kind of how I'm interpreting this. So, like I said though, I am going to replace this guy. It's a 3906, and then I'm going to see what that does. I mean, those are about a penny a piece, so I'm going to go ahead and replace that and see what happens. Okay, I replaced that guy, and it did not change anything. It's working right now, but that's because I've touched that probe to it. If I turn it off, turn it back on, it will not work until I put that probe to pin 1 and then reset it, which I can do. We'll see, it'll be nice and fuzzy. Nope, it settled right down when I touched it. Hit reset, and it's working. It's a capacitor problem. It's either a capacitor in the circuit or it's the crystal itself. Is the moment that I introduce some capacitance to pin 1, it fixes it. So I am going to look at the capacitors, all the capacitors that are basically attached to pin 1 of this chip. So let's go back over to the schematic. Okay guys, I removed a bunch of these capacitors over here. I did replace one of them that I had an exact match, but I tested it and it was fine. But you see this empty spot here, C91. Over on that schematic I have, it says that C91 is unpopulated. So I left it unpopulated. It's right here. I had taken it out and tested it, and it tests fine. But it's left out in the schematic. It specifically says unpopulated. So I left it unpopulated, turned it on, and it works. I just had to reset it. It went to sleep. But even if I turn it off, remember how you turn it on and it wouldn't work? And turn it back on, works perfect. I will turn it off, turn it on, turn it off, turn it on, off, on, leaving that unpopulated is what fixed it. I don't know why it was in there, to be honest. I mean, it specifically says that is, if you see, it says C91. You see that right next to it, C91? Let's go look at that schematic. Come on over. Coleco. And we'll come on over to our schematic. C91, not installed. That was it. You know, it's a mystery why that was in there. I don't get it. Yeah. Anyway, It works now. Now all 4 of them are working good. Just wait for those connectors to come in, the edge connector for the cartridges. And I'll pick back up after that. Now we've got all 4 of them working perfect so far. So, alright guys, see you later.